Hi lads, so just back again with another video recording of a solution there for 23 to 31. Okay, I am delighted with this new technology. I feel like I'm kind of catching up with everybody else. But anyway, hopefully you find these helpful anyway. Okay, so let's have a look here. We're looking at question number 20. So this is the question from the book here. The first thing I need to do is make sure I've got the same base, 2 and 2, that's fine. Next, I'm going to use my rules of logs. So I'm adding the two of these. You know adding is related to multiplication, so I can rewrite as log base 2 and multiply the two of these, okay, equals to 3. So I multiply them out. Then I can use my rule, the base stays the base, and these two switch. So my base is 2, that stays the base. These two switch. So 3 hops over here and becomes a power, and this goes over to the other side. That's a very, very important rule, okay? Then you just come down to the power of 3 is 8, so if x squared minus 2x is equal to 8. Sorry, now I need to scroll down. Yeah, that's still recording, sorry now. Okay, so I just solved my quadratic now as normal, straight brackets, x and x, 4 and 2, minus plus, x equals 4, x equals minus 2. You cannot have a minus value, as if you put into your calculator to get a minus log, it's undefined, it will not work. So you could not end up with a minus up here. Is that okay? You can't end up with a minus log, so you only accept x is equal to 4. Okay, and so to question number 24. Again, I'm checking to have the same base, 10 and 10, I do, so that's fine. I can apply my rules of logs. If it's log of something minus log of something, and they have the same base, I can use my rule to say, right, subtraction is related to division, so it's that over that. There it is. Now apply that rule, the base stays the base, and these two switch. So my base is 10, that stays the base, and these two switch, okay? And then my log is gone because I've applied that rule to the top of page 21. So it's 10 to the power of 1 is equal to this thing. Then I cross multiply, so that goes up there and multiplies. 10x squared minus 10, bring this over, minus x squared minus 6 is 0. And you should recognize this as what? The difference of two squares, okay? So you have 9x squared minus 16, the difference of two squares. So the square root of that is 3x, the square root of that is 4, so 3x plus 4, 3x minus 4, okay? And then just solve, you put each bracket equal to 0, so you get 3x is equal to minus 4, when that goes across, x is equal to minus 4 over 3. 3x is minus 4 is equal to 0, 3x is equal to 4, x equal to 4 over 3. Accept both. Now, why am I saying I'm accepting a minus here, but I didn't the last time? If you look up here, your x here is going to be squared. So remember, anything squared is positive, so they will work out to be positive. Okay, because you have your 4 over 3 is bigger than 1, so something bigger than 1, take 1, that will work out to be bigger than 1, that's bigger than 1, so I'm all good. Okay, but if it was just an x here by itself with nothing, I wouldn't be able to accept that one. Because it's squared, it's fine. On to number 25. Log 2x minus log x minus 7 is equal to log 3. Okay, so there's no base here. If there's no base, it holds true for whatever your base is. Okay, so if there's no base, it's fine. I would just say, right, that's like the base 1. Okay, so or just it holds true for any base. You could put base 10, 10, 10 if you like. All right. Now, how do I solve this? Again, subtraction becomes division. So it's going to be 2x over this one, using page 21 all the time for these, okay? And it's the log of that is equal to the log of that. Remember, if you've log base something on each side, that can kind of cancel with that, okay? So they're gone. So I just am left with 2x over x minus 7 is equal to 3. Cross multiply and solve. Over here we have x is equal to 21. I'm happy with that. Okay, on to 26. Check, do I have the same base all the way across? I do. There's no base there, so it holds true for every base. That's fine. What am I changing to? Well, I'm going to change addition to multiplication. So just the log stays here. Multiply this one by this one. And also, what else do? I bring that 2 up as a power. Okay, bring that 2 up as a power. So I'll have log and log on both sides, and they can cancel off with each other. So I can put this thing equals to this. okay? And just solve it as a normal quadratic. All right, straight to brackets, x and x, 3 and 2, and so on. You do not accept this because we do not want a minus 2, because if I put in a minus 2 here, can't get the log of a negative number, so reject that one. On to number 27. Do I have the same base all the way across? I do, so I'm happy with that. So addition is related to multiplication, so it's log base 10 that plus log base 10 that. Change it to multiplication, it's x multiplied by 17 minus 3x. There you see it, is equal to 1. Use your rule, the base stays the base, and these two switch. So the base is 10 to the power of 1 is equal to that. That was done the very first day, okay? Sorry now. So yeah, and then you're just solving a quadratic. Now, if you want to split that out, no problem. You say 3 multiplied by 10 gives me 30. Two factors that add up to 30 and multiply to 30 and add up to minus 17 would be a 2 and a 15, wouldn't it? And then you go factor that out. I'm showing you a bit of a shortcut here. So I put into the first part of the bracket two things that multiply to give me 3x, 3x by x, two things that multiply to give me a 10, 5 and a 2. Outsides give me minus 15, insides give me minus 2. And I showed a few people in the class that way. I did on the board, but please put out the longer way if you find that confusing. Okay, it's a bit of a shortcut if you're very, very good at solving these, but you might want to stick with the shorter way if you like. Oh, sorry, with the long way and do it out on the side. You get the same answer as both are positive, so I'll accept that. On so to 28. Log base 10 x squared minus 4x minus 11 is equal to 0. Okay, straight away, base stays the base and these two switch. Okay, so the base stays the base, so 10 is the base to the power of 0 gives me that. It's kind of like going around in a circle. 10 to the power of 0 gives me this one. So then anything 10 to the power of 0 is 1. Anything to the power of 0 is 1, remember, and you're just solving a quadratic as normal. And I have two answers there. I have a minus 2 and a 6. So I'm going to accept the minus 2 because it's squared there. And that will all work out to be positive. I'm just thinking there because x squared will be 4. That would be a plus 8, which would be 12. 12 take 11 is 1. So that's fine. Yeah, that's why you accept the minus there. So you just have to double check it. Carrying on then with 29. Okay, 29 is a small bit tricky. So I'm starting off with this. I'm just going to play around with this until I just have x and y. Get rid of your logs. So bring up your 2 as a power up here. Apply your rule. 2 to the power of y gives me x squared. Okay. Then I'm going to use that over here. Okay. So play around with this. 2 to the power of this gives me 2x, and my logs are gone. You can split that out using your rules of indices on page 21. The very first rule, addition is related to multiplication. So that'll be 2 to the y by 2 to the 4. 2 to the 4 is 16. Now, instead of 2y, I found out that can be written as x squared. There it is equal to 2x. And then you're just solving as normal. All right. On to number 30. For 30, what did I do for that one? You use your multiplication rule again. So it's x by y, can be written like that. Then you do 6 to the power of 1, gives me xy, and x can be written as 6 over y. Then you just use substitution to solve it. So solve your simultaneous equation. So you've got x is equal to from that one, so you just sub it into the other one. All right, you just sub it into the other one using substitution to solve. And that works out just to be a quadratic again, which should be fine for you. Don't forget to get your y value at the other side. So you get 2 and 15 you got your y's, 2 and 15. Go back and sub in here to get your x's, and you get 2 values for each. And on to 31, I think this is the last one. Okay, you're using a change of base rule. I'm going to change this one. I don't have the same base, so bring it out to the side. Log over log x and 2. Introduce a new base. I'm going to have the base x, x and x. There it is, because I'm copying what's over here. Then that becomes anything to its own base is 1. There it is, over log base x 2. Okay, so that can sub back in over here then. There it is. And then you're using substitution. So I have log base x 2. I'm letting that is equal to y. So everywhere I see that, put in a y. There it is. Multiply across by y to get rid of your fractions. So that will give me 4y squared minus 1, because y cancels with y, minus 3y. Okay, I see that turns into a quadratic, so I just solve that. So I have 4y squared. So I'm going again straight to brackets, 4y and y, 1 and 1. Do it out the long way if you're unsure. And you get two answers there. You have a minus a quarter and a 1. And then what do? I let each one of those answers equal to log base 2x, because remember we're using substitution. Y is equal to log base 2x. I have two values for y, so you put each one equal to those. How do I solve that then? Just using my rules of indices, x to the power of that gives me that, and then bring that underneath the line to make it a positive power, cross multiply, put each side to the power of 4 to get rid of your quarter. And the other side then works out a lot easier. X to the power 1 gives me 2, so x is equal to 2. Last one is the same story, okay? You use your change of base rule out on the side, put it back in, and get log base x everywhere. Everywhere I see it, use a y subbing in. Multiply across by y to get rid of your fractions. And then I use my quadratic, solve a quadratic, let each one equal to whatever you did for your substitution there. Don't forget to do that at the end. Okay, I hope that was of help to you lads. Please let me know if you need anything further. Let me stop my recording. Thank you. Bye.